So, and this video is a continuation of the series resonance circuits which we have already discussed. So, we will see further detail about this series resonance circuit. So, from this circuit diagram, I can write Vs is equal to I into Z, right? So, what is I? What is Z? Z is equal to R plus J XL minus JXC, right? So I can write I is equal to Vs divided by R plus JXL minus JXC. So this I can also write it as Vs divided by R plus J omega L minus 1 divided by omega C J. Okay. So for series resonance circuit, we know that I it is like this, right? The graph look like this. So this is nothing but Vs divided by R. Okay, Vs divided by R, because at resonance we can see you have only resistance. Okay. So if I take the 3 dB value, that is Vs divided by root of 2R. Okay, at that frequency, this is called as half power bandwidth. So this is nothing but F1 and this is nothing but F2. Okay, so we know that the bandwidth is equal to F2 minus F1. Okay, so I can equate this I can write it as Vs divided by root 2 of R, that is equal to Vs divided by R plus J omega L minus J by omega C. Okay. So Vs get cancelled out. So you will get 2R is equal to root 2 of R is equal to R plus J omega L minus J omega C. So if I take magnitude of this value, it is so this is nothing but I, right? So if I take the magnitude of I will get for magnitude of I only it should be Vs divided by 2R. So that has to be equal to Vs divided by R plus omega L divided by minus omega C whole square. Okay, this is how it is. Alright. Okay, so if I take square root of this value, I'll get 2R square is equal to R square plus omega L divided by omega C the whole square. Okay, so I can write R square is equal to omega L divided by omega C the whole square. So you can get the two values for R, right? Because I can write this is equal to root of R square, that is equal to omega L minus 1 divided by omega C. So this has to be omega 1. If it is omega 1 L divided by omega 1 C, that is equal to minus R. Okay, because if I take root of R, I will get plus R minus R. Okay, so this has to be plus or minus R. Okay, so for omega 1 it is minus R. For omega 2 it has to be plus R. So this is my first equation, this is my second equation. So I am going to add this one and first and second equation. So if I add these two equations, I will get omega 1 L divided by omega 1 C plus omega 2 L minus 1 divided by omega 2 C, that is equal to 0. Okay. So if I take L common, I will get omega 1 plus omega 2 L is equal to 1 divided by omega 1 plus 1 divided by omega 2 divided by C. So this is equal to omega 1 plus omega 2 divided by omega 1 omega 2 of 1 divided by C. So here omega 1 plus omega 2, this L I am going to keep it here. This omega 1 plus omega 2 get cancelled out. So we will get omega 1 omega 2 is equal to 1 divided by LC. Okay. So we know that omega naught is equal to 1 divided by root of LC. That is omega R, that is resonance, angular resonance frequency. So what is omega naught square? That is equal to 1 divided by LC. So this is your fourth equation and this is your third equation. Okay. So you substitute here. Substitute 4 in 3. So you substitute 4 in 3. We will get omega naught square is equal to omega 1 omega 2. So omega naught is equal to root of omega 1 omega 2. Okay. So this is your fifth equation. So from 1 and 2, if I add, I will get omega 1 omega 2 is equal to omega naught square. So if I subtract this, okay, if I subtract these two equations, if I subtract 2 minus 1, I will get omega 2 L minus omega 2 C minus omega 1 L plus 1 divided by omega 1 C, that is equal to 2R. Okay. So omega 2 minus omega 1 of L minus plus 1 divided by omega 1 minus 1 divided by omega 2 of 1 divided by C is equal to 2R. Okay. So you divide the whole term by L. If I divide the whole term by L, I will get omega 2 minus omega 1 divided by omega 1 omega 2. Okay, 1 divided by LC, that is equal to 2R by L. Okay. So what is what is omega 1 omega 2? It is equal to omega naught square. Omega naught square is so we substitute here omega 2 minus omega 1 plus omega 2 minus omega 1 divide by omega naught square. Omega naught square is LC. So we will get LC divided by LC, that is equal to 2R divided by L. So here LC and LC get cancelled out. So we will get 2 times omega 2 minus omega 1 is equal to 2R by L. So what is omega 2 minus omega 1? That is equal to R by L. Okay. So this is nothing but bandwidth. Okay. So if I measure in terms of F2 minus F1 means that is equal to R divided by 2 pi L. Okay. So this F2 minus F1, I can write it as R divided by 4 pi L plus R divided by 4 pi L. So if I solve, I will get R divided by 2 pi L plus Fr minus Fr. Okay. So I can write this whole term as F2 minus F1 is equal to like this. So I can write F2 is equal to Fr plus R divided by 4 pi L. Okay. What is F1? F1 is nothing but Fr minus R divided by 4 pi L. Okay, and so this is your 6th and 7th equation. See here, Fr is nothing but omega R divided by 2 pi. Okay. Otherwise, I can write it as omega naught divided by 2 pi. They both are same. Okay. So here I can write this equation. I can also write it as Fr plus bandwidth divided by 2. Right, this I can write as Fr minus bandwidth divided by 2. So if I have to write it in terms of omega 2 is equal to omega naught plus bandwidth divided by 2, or I can write omega 1 is equal to omega naught minus bandwidth divided by 2. Okay. So now let me explain this one. So if you see the graph, so if here the R value is small, okay. Here the R value is small. So if the R value get increased, okay. So if the R value get increased means obviously my R values, R is nothing. If R is 2R, it is increasing, right? It is increasing, right? If it is increasing, you can see the bandwidth is increasing and the selectivity get reduced. So if R is less means Q is large. Here Q is small, okay, but bandwidth is increased. So you can see the Q is inversely proportional to that of bandwidth, okay. So I can write what is Q? Q is equal to, Q is nothing but quality factor. Quality factor is inversely proportional to that of bandwidth, okay. So Q is nothing but Fr divided by the bandwidth. Okay. So what is bandwidth? Bandwidth is here is R divided by, what is bandwidth? Bandwidth is R divided by 2 pi L. Okay. So you substitute here R divided by 2 pi L. So this is nothing but 2 pi Fr is omega R. Omega R L divided by R. This is nothing but XL divided by R. This I can also write it as XC divided by R. So if I write XC divided by R, that is nothing but 1 divided by omega R C R. Okay. So I can write Q. Okay. Q is Q is defined as maximum of energy, so maximum of peak energy stored in the circuit, okay, stored in the circuit. So if I want to store, I need the reactance circuit, right? That is Xi. Divide by energy dissipated. Energy dissipated, it is due to the resistance, right? During each cycle of oscillation. Okay. So you can multiply 2 pi, 2 pi. Okay. So if I solve this one, you will get the same answer only. Okay. So 2 pi, what is the peak energy stored in the inductor? 1 divided by 2 N I square. Okay. Divide by energy is equal to power into time. So power I can write it as 1 divided by 2 I square R. Okay. So time I can write it as 1 divided by F. Okay, that is frequency. Okay, so here this will get cancelled out, and I will get 2 pi F L divided by R. That is nothing but XL divided by R. Okay. So if we want to measure it for capacitor, means XC means you will get XC divided by R. Okay, that is nothing but 1 divided by omega naught C R. Okay. So if Q is large means bandwidth is less. Okay, if Q is large means selectivity is also large. So what is selectivity? Okay. So the sharpness of the peak in a series resonance circuit is measured quantitatively. Okay. And it is called as Q factor. Okay. Q means quality factor. Okay. So what is selectivity? Selectivity of the circuit is a measure of its ability to reject any frequency either side of this point. That is F1 and F2. Okay. So if the lesser the selectivity, we have wider the bandwidth. Okay. So I can write, we know that VL is equal to I into XL, right? I into XL. So this I can write it as Vs divided by R, right? Vs divided by R. So what is XL divided by R? That is equal to Q into for modulus. Okay, that is equal to Q into Vs. Similarly for Vc, I can write it as I into Xc. That is equal to Q into Vs. Okay. So now let us discuss one problem based on this. So suppose if R is given as 2 ohm and L is equal to 1 millihenry and C is equal to 0.4 microhenry. Find FR, that is resonance frequency. So you know that the formula, right? FR is equal to 1 divided by 2 pi root of LC, or omega R is equal to 1 divided by root of LC. So if you solve, you will get 50K radian per second. So this is your unit. Okay. So next they are asking about half power bandwidth. Okay. Half power frequency. So half power frequency means you have to go in this formula. Okay. This is your half power frequency. So omega 2 is equal to omega naught plus bandwidth divided by 2. Bandwidth divided by 2 is nothing but R by L. Okay. So what is omega 2? Omega 2 is equal to omega R plus R by 2L. Okay. So if we substitute, this is nothing but 50K. Okay. This is 50K. And what is R? R is nothing but 2 divided by 2 minute. So this is nothing but 51K. Okay. Radian per second. So we know that omega R is equal to root of omega 1 and omega 2. So omega 1 is equal to 49K. So this is your radiant frequency. First one, and this is your second one. And third one is Q factor. Okay. Quality factor. Quality factor and bandwidth they are asking. So we know that bandwidth is equal to R by L. Okay. R by L is nothing but 2 kilo radian per second. And what is Q factor? Q factor is equal to FR by bandwidth. Okay. Or otherwise I can write it as omega naught L divided by R. So what is omega naught? Omega naught is 50K. 50K. R L is 10 power minus 3 and U is 2. So you'll get 25. So if for high Q circuit, what is high Q circuit means? The Q value must be greater than or equal to 10. So here you can see Q value is 25. So this is nothing but a high Q circuit.